Hi, this is Jaganathan, Assistant Professor, Department of AI Department. Today I discuss about CPU scheduling. Today we discuss about introduction, types of CPU scheduling. In that types of CPU scheduling, two types we have to describe here, FCFS and round robin. And what are the references books are we followed to completed CPU scheduling. Introduction about CPU scheduling. CPU scheduling is that scheduling of process work is done to finish the work on time. CPU scheduling is a process that allows one process to use a CPU while another process is delayed in standby mode due to unavailability of any resources such as I/O, etc. Thus, making full use of CPU. The purpose of CPU scheduling is to make the system more efficient and faster, etc. CPU scheduling is a key part of how an operating system works. It decides which task or process the CPU should work on at any given time. Okay, here we go for types of CPU scheduling. Whenever we want to go for a scheduler, whenever in each and every CPU, one process will be going to running together. Okay, here we go for types of CPU scheduling, non-preemptive scheduling and preemptive scheduling. So what is the difference between non-preemptive scheduling and preemptive scheduling? First we go for non-preemptive scheduling. A scheduling discipline is non-preemptive. It's once the process has been used with CPU, the CPU cannot be taken away from the process. Mainly we focus on that the running process keep the CPU until it's voluntarily give up the CPU. Okay, first we based on that process exits, and next we go for switch to block states. These are the things we performed in non-preemptive scheduling. Mainly we focus on that one process will be entered into the CPU. That process will be completed. The next process will be going to initiate to execute in non-preemptive scheduling. In preemptive scheduling, whenever one process will be entered into the CPU, immediately we want to stop. We want to interrupt that. New process will be going to executed. Okay, mainly we focus on that these two CPU scheduling. Preemptive scheduling is nothing but the running process can be interrupted and must release the CPU, can force it to give a CPU. Okay, these are the main types of CPU scheduling. First one is that first come first server, second one is a shortest job first, and third one is a round robin, and fourth one is a priority scheduling. Okay, in that for CPU scheduling, based on that we want to compare. Previously we told non-preemptive scheduling and preemptive scheduling. Okay, this major for CPU scheduling has been going to applicable based on that non-preemptive as well as the preemptive. The first one is belongs to that first come first server. In short form, they have FCFS. Okay, in first come first server, it is only applicable for non-preemptive scheduling. It is not applicable for preemptive scheduling. So why means what are the processes are available in the ready queue? That process will be once the process has been going to started, that process has been going to completed, the new process will be going to taken. Okay, based on the condition that non-preemptive scheduling only is applicable for FCFS. It is not applicable for preemptive scheduling. And second one is belongs to that SJF, that is the shortest job first. It is applicable for both non-preemptive scheduling as well as the preemptive scheduling. And priority scheduling also is applicable for both non-preemptive scheduling as well as the preemptive scheduling. And round robin, that fourth one is a round robin. That is, it is not applicable for non-preemptive scheduling based on the time quantum that every time that based on once the time quantum has been going to reach the new process will be arrival. Okay, based on the conditions that non-preemptive scheduling is not applicable for round robin, so it is applicable only in preemptive scheduling. Okay, coming to that, these are the terminologies used in CPU scheduling. Okay, first one is belongs to that what is meant by arrival time. That time at which the process arrives in the ready queue. Okay, based on that ready queue only that process will be entered into the CPU. And next one is belongs to that completion time. The time at which process completes its execution. Okay, that based on the each and every process that it can be considered as a burst time also. Based on the burst time, that process has been going to completed. And next one is belongs to that burst time, the time required by a process for CPU execution. And next one is belongs to that round robin turnaround time, the time between difference between completion time and arrival time. Okay, that is the formula we have to calculate that average turnaround time. Average turnaround time equal to completion time minus arrival time. Okay, and next we go for waiting time, the time difference between the turnaround time and burst time. Okay, we have to calculate the average waiting time, turnaround time minus burst time. Okay, these are the things we able to perform in terminologies used in the CPU scheduling. Okay, what is meant by arrival time, what is meant by completion time, what is meant by burst time, what is meant by turnaround time, and next one is the waiting time. Okay, now we have to go for first CPU scheduling, first come first server scheduling. Whenever we want to, what are the processes are available in the ready queue, that process will be one by one, that process will be entered into the CPU, that process has been going to completed. Okay, based on the conditions, it will, this process has been going to applicable. Okay, we have go for an example. The number of process, okay, three process has been going to available in the first come first serve scheduling, and second one is based on the burst time. Okay, how much time need to complete based on that each and every process, that burst time also it will be given. That process 1 P1, that will be burst time is belongs to that 24, and P2 3, P3 3 milliseconds. Suppose that process all the process arrives in the order P1, P2, P3. So this is belongs to that first come first served scheduling. So all the process are entered into the ready queue based on the time durations. That here we mention about arrival time as well as the non-arrival time. Okay, whenever we want to focus on each and every CPU scheduling, we want to go for that arrival time as well as the non-arrival time. Okay, if you have arrival time, based on the time duration, that process one by one, that process will be entered into the ready queue. So based on the scheduling algorithm, that process has been going to executed in CPU. Okay, here first we go for these are the three processes are allocated in first come first server. Here we have to draw the Gantt chart based on the scheduling. That first process, the burst time is belongs to that 24 milliseconds. So we have to taken as that no waiting time is will be start from 0 to 24. And second process is belongs to that 3 milliseconds only. So that 24 plus 3, 27. That also it will be used in the Gantt chart. And process P3 also it belongs to that burst time is belongs to that 3 only. So that 27 plus 3, that is a 30. Okay, so that also it will be going to draw the Gantt chart based on the scheduling. Okay, now we go for we want to finding the terminologies are used in the CPU scheduling. We want to finding the arrival time, burst time, completion time, and turnaround time, waiting time. Okay, here P1, P2, P3, all the processes belongs to that 0 milliseconds only. So there is no arrival time. It will be 0 only. All the process will be available in the ready queue only. We know that burst time that will be given in the example. P1 have taken 24 milliseconds, and P2 have 3 milliseconds, and P3 have 3 milliseconds. We know based on the arrival time, we have to mention that here we want to calculate the completion time. Whenever arrival time is a 0, so we want to calculate that completion time equal to burst time minus arrival time. Okay, here we completion time and each and every time that ready queue, that process has been going to available, and 0 milliseconds all the process will be entered into the ready queue. So that no arrival time has been going to calculated. Here arrival time for each and every process is belongs to that 0 only. So completion time for each and every burst time 24, and 24 plus second burst time is belongs to the 3. So 27, and the third burst time is belongs to the 3. So 27 plus 3, 30. Okay, here we want to calculate that. Already we told terminologies are used in CPU scheduling. How to calculate the turnaround time equal to completion time minus arrival time. Okay, here completion time for P1 is belongs to that 24, and arrival time for each and every process is 0 only. So here what is the completion time for each and every process? That will be same as turnaround time also. Okay, so completion time for P1, that is a 24, completion time for P2, that is a 27, completion time for P3, 30 only. So next we want to calculate the waiting time. Here we have to write the formula how to find the waiting time for each and every process. Waiting time equal to turnaround time minus burst time. Okay, here turnaround time equal to 24 minus 0. 24 minus 24. Burst time also is belongs to that 24, and turnaround time also is belongs to that 24 only. So 24 minus 24, that is a 0 waiting time for P1. So that first process will be enter into the CPU. So that waiting time of first process is belongs to that 0 only. So next waiting time, how to calculate the waiting time for P2? Same, turnaround time minus burst time. So here turnaround time is belongs to that 27 minus burst time is belongs to that 3. So that is waiting time for P2 is belongs to that 24. And next waiting time for P3, how to calculate means based on that turnaround time minus BT. Here turnaround time equal to P3 turnaround time means that is a 30, and by burst time equal to 3. So 30 minus 3, 27. Okay, since all the process arrives at the same time, that is a 0 milliseconds only. So there is no arrival time is 0 only. So the turnaround time as well as the completion time are same only based on the arrival time. Okay, here waiting time for P1 0, P2 24, P3 equal to 27, and we want to finding the average waiting time, that is a total waiting time divided by number of process. So that is a formula we have to find the average waiting time. So that is the first waiting time for P1 0 plus 24 plus 27. That 24 is belongs to that waiting time for P2, and 27 is belongs to that waiting time for P3. So 0 plus 24 plus 27 divided by number of process, that is a 3 process, that is a 17 milliseconds. Millisecond, that is a waiting time for each and every process. Okay, similarly, we want to calculate the turnaround time for each and every process. Already we calculated 27 plus 24 plus 27 plus 30. So divided by number of process. So that is each and every turnaround time for each and every process belongs to that 27 only. Okay, this is the example for arrival time for all the processes belongs to that 0 only. Okay, whenever we want to go for arrival time has been mentioned for each and every process. On the time, what is the average waiting time? What is the average turnaround time? We have to see that. Okay, this is the example for average time for each and every process. P1 is belongs to that arrival time is a 0, P2 is nothing but a 1, and P3 that arrival time is the 2 milliseconds. Okay, and burst time is a common for previous example, that is a P1 equal to 24, P2 equal to 3, and P3 equal to 3. Okay, here we mentioned that completion time. Okay, here first process P1, P2, P3 based on that order, that all the 3 processes has been going to stored in the ready queue. Okay, one by one based on the algorithm, based on the CPU scheduling algorithm, the first process will be entered into the CPU, that is a P1. So how much time it will take now? That is the burst time is the 24 milliseconds. So 24 milliseconds, that first process has been going to completed. That P1 completion time is the 24. And next, that is the arrival time for each and every second process. P1 process belongs to that arrival time is a 0, and P2 arrival time is the 1. So here after 1 milliseconds in that ready queue, that is P2 will be going to store. Okay, after 2 milliseconds, that P3 also it will be entered into the ready queue. Okay, based on the time duration, that all the process will be entered into the ready queue. Based on the conditions, based on the algorithm, we have to go into executed one by one. So the first process burst time is belongs to that 24 milliseconds. Okay, in that first process need to complete. Remaining process are being entered into the ready queue. Okay, initially in that ready queue, only one process is available. That is the P1 process will be available. That is the arrival time of P1 process is the 0 only. So that only one process is available in the ready queue. So that P1, that first process has been going to initiate to start. So this is belongs to that non-preemptive scheduling algorithm. So that is the burst time is 24 milliseconds. That P1 will be enter now. After finishing the 24 milliseconds, that next process has been going to initialize to execute. Okay, like that it will be go for first come first server. Okay, here completion time for P1 is belongs to that 24, and P2 completion time is belongs to that 27, and P3 completion time is belongs to that 30. Okay, now we able to find the turnaround time. As usual, that formula will be going to applicable. Completion time minus arrival time. Okay, here completion time for P1 is belongs to the 24. Arrival time is the 0. So 24 minus 0, 24. And next P2 process, that is the completion time for P2 is belongs to the 27. Arrival time of P2 is nothing but a 1 millisecond. So 27 minus 1. So that is belongs to that 26 only. And next P3, that is the completion time of P3 is belongs to the 30. So arrival time of P3 process belongs to the 2. So 30 minus 2, 28. So this is the this is the turnaround time for each and every process. P1 24, P2 26, P3 28. And next waiting time for each and every process. So the first process P1 will be start now. So that is that waiting time is 0 for based on the formula also it will be going to applicable turnaround time minus burst time. So turnaround time for P1 is belongs to that 24 and burst time is 24. So 24 minus 24 0. And next P2 process to find the waiting time 26 minus 3, that is a 23. And P3 28 minus 3, 25. Okay, now since all the process arrives at different time only. So based on the arrival time for P1 0, P2 1 and P3 is belongs to that 2 only. So we need to find a waiting time for each and every process. P1 equal to 0, P2 equal to 23 and P3 equal to 25. Okay, now we able to find the average waiting time as well as the average turnaround time. So we need to calculate that average waiting time for each and every process is belongs to that 24 milliseconds. Average turnaround time that is belongs to that 26. In previously there is a same example we mentioned. So here previously without arrival time the average waiting time is belongs to that 17 and average turnaround time is belongs to that 27 only. Suppose that process arrives in the order P2, P3 and P1. So okay, we want to prepare the Gantt chart based on the scheduling process P2, P3, P1. So that P2 has burst time is belongs to the 3. So 0 to 3. And P3 is belongs to that burst time is belongs to the 3. So 3 plus 3, 6. And P1 is burst time is 24. So 6 plus 24, 30. The waiting time for P1 is belongs to that 6 milliseconds and P2 0 and P3 equal to 3. So we want to finding the average waiting time, that is a 3 only. Okay, based on that that much better than previous cases based on that convoy effect, short process behind long process. Consider one CPU bound and many IO bound process are available in the CPU scheduling. Okay, that is a convoy effect has been going to performed in whenever that smallest burst time has been going to executed first. Okay, that average waiting time as well as that everything that will be reduced based on that any order. That is the reason only we want to go for different types of CPU scheduling algorithms are available in operating system. Okay, and we see about advantages and disadvantages for the first come first server. The advantages for first come first server CPU process schedulings are, in order to allocate process, it uses the first in first out queue only. Okay, based on the ready queue, which process will be entered into the ready queue, that process has been going to executed first. It is a straightforward and easy to implement. In FCFS situation, preemptive scheduling. Okay, this preemptive scheduling is not applicable in FCFS if there is no chance for process starving. Okay, that is also one of the advantages for FCFS. And disadvantages for FCFS CPU process scheduling. It has long waiting time. Short process that are at the back of queue have to wait for the long process at the front to finish, lead to chance of occurrence of convoy effects. And not an ideal techniques for time sharing systems, because of simplicity that FCFS is not very efficient. Okay, these are the disadvantages are applicable in first come first serve CPU process scheduling. And next we go for round robin. Okay, each process get a small unit of CPU time, that is belongs to that quantum time Q. Usually 10 to 100 milliseconds after this time has been elapsed today, and the process is preempted and add to the end of the ready queue. Okay, once the time duration has been going to completed, the new process will be enter into the CPU. So that the current process will be again it will be restored in the ready queue. Okay, and if there are n process in the ready queue and time quantum is q, then each process get 1 by n of CPU time in consists of almost q times units at 1. No process wait more than n minus 1 quantum time. Okay, the timer interrupt every quantum to schedule the next process. Okay, based on the time durations that each and every process, the current process has been going to interrupted, new process has been going to initiate to start. Okay, this is the example, same example have previously we used FCFS. Example of round robin with time quantum is belongs to that 4 only. So every 4 milliseconds that current process has been interrupted, that will be stored in the ready queue. Next process will be entered into the CPU. Okay, here that is a Gantt chart. First, how many time it will take the P1 has been going to executed in the CPU means 16, 6 time it will be that P1 0 to 4, and next 10 to 14, and 14 to 18, and 18 to 22, 22 26, 26 to 30. Totally have 6 time that P1 has been going to entered into the CPU. Okay, here P1, P2 and P3, that is only 3 milliseconds, that less quantum time only. So that each and every P2 will be enter once at a time. Okay, so that initially it will be started, that process has been going to completed. So based on the round robin, we need to go for that. Okay, time quantum equal to 4. So each and every process after 4 milliseconds, the current process has been going to interrupted, that will be stored in the ready queue. Okay, the new process, the next process will be initiated to execute. So 0 to 4, P1 has been going to initiate to start. So next interrupted, that P1 again it will be going to store in the ready queue in the last. So next process P2. So that completion time for P2 is the 3 milliseconds. It is lesser than the time quantum. So we need to take 3 milliseconds only. So 4 to 7, that P2 will be going to complete it. And next P3 also, that is less than quantum time. So 3 milliseconds only. 7 to 7 plus 3, 10 milliseconds. that P3 also it will be going to completed, and the remaining, that is only one process are available in the ready queue. So that P1 again it will be start from P1. So 10 to 14. Okay. Again that interrupted, that P2 P1 will be stored in the ready queue. Again it will be going to initiate to execute. 14 to 18. Similarly 18 to 22, 22 to 26, 26 to 30. Okay, based on the sixth time that again that P1 has been into initiate to execute in the CPU, interrupted one by one. It is a higher average turnaround time than SJF. That is the shortest job first, but better response based on that quantum should be large compared to the context switch time only. So how many times that is each and every process has been going to entered into the CPU. Okay, that also it will be going to performed here. Okay, based on the Gantt chart, we need to calculate the turnaround time, waiting time, completion time, everything. Okay, here also there is a arrival time for each and every process is a 0 only. So that is a completion time for P1 is belongs to the 30 milliseconds, and P2 7, and P3 is belongs to the 10 only. Now we calculate the turnaround time, that is a CT minus AT, that is a completion time minus AT. Already we told the arrival time for each and every process is a 0. What is the completion time? That will be same as turnaround time only. So 30, 7, 10 only. And waiting time to be calculated for each and every process, that is a first turnaround time 30, and burst time equal to 24. That is a 30 minus 24, 6 only. That is a waiting time for P1. And next turnaround P2 turnaround time is belongs to that 7, and burst time equal to 3. 7 minus 3, that is a 4. And turnaround time for P3 10, and burst time for P3 there is a 3. So 10 minus 3, 7 only. Okay, based on that we want to calculate the average turnaround time as well as the average waiting time. Okay, based on the formula only we able to find the average waiting time as well as the average turnaround time. Okay, this is the time quantum and context switch time. Process time equal to 10 milliseconds only. Each and every process, that maximum time taken is belongs to the 10 only. So here we mentioned that time quantum for first one is at 12 only. So there is no context switch will be happen in first case. So process time is that 10 only. That quantum has been going to increase rate 12 only. So there is no each and every process that will be going to each and every process that will be initialized in the within a time duration only. That is the context switch equal to 0 only. No switch, process has been going to interrupted. And second case, that is the quantum size is belongs to the 6 only. The process time equal to 10. So after 6 milliseconds, it will be interrupted. The new process will be arrival. So that's a context switch is belongs to that 1 only. So next third case, that is a process time equal to 10, and quantum is belongs to that 1 only. So that is a 9 contact switches will be happen in third cases. So based on the quantum time, it will be reduced now. There is a more number of contact switches that has been going to created. We want increasing the quantum time now. We have to reduce the contact switches based on the process time. Okay, these are the reference books has been followed to completed for CPU scheduling. Operating System Concept Essential 9th editions by Silberkatz, and second book is belongs to that Operating System Internal and Design Principles 5th edition William Starling. And online resources also it will be available to learn more in CPU scheduling. Thank you.